In this video, we will be learning about ionic compounds, including their properties and how to write their chemical formulas. As the name implies, ionic compounds are made up of ions. They consist of repeating patterns of positively charged cations and negatively charged anions held together by strong electrostatic forces called ionic bonds. The chemical formula for an ionic compound represents the smallest whole number ratio of ions needed to create a neutral compound. The smallest piece of an ionic compound is called a formula unit. In ionic compounds, the overall charge is always zero, even though the compound is made from charged particles. Unlike molecular compounds, electrons are not shared between atoms in ionic compounds. This image shows sodium chloride, NaCl, which is table salt. Although there are many sodium cations and chloride anions in a sample of sodium chloride, the smallest repeating unit contains one sodium ion and one chloride ion. Sodium has a 1 plus charge and chloride has a 1 minus charge, so the charges add together to equal 0. Ionic compounds typically have high melting points, meaning they are usually solids at room temperature. Although ionic compounds can often contain metal cations, they do not conduct electricity in the solid state like pure metals do. Electrical conduction requires the movement of charged particles, and in the solid state, the ions are locked into place and cannot move. However, if an ionic compound is melted into a liquid or dissolved into water, the ions are free to move, allowing the solution to conduct electricity. The ions within ionic compounds can be monatomic, meaning they consist of a single atom, or they can be polyatomic, meaning they contain multiple atoms with an overall charge. This calcium ion is a monatomic cation because it consists of one calcium atom with a 2 positive charge. Recall that the 2 positive charge means that calcium has lost 2 electrons, so it has more protons than electrons. Polyatomic ions contain multiple atoms that behave as one charged unit. For example, ammonium is a cation made out of 1 nitrogen atom and 4 hydrogen atoms with an overall 1 positive charge. Nitrate is a polyatomic anion made out of 1 nitrogen atom and 3 oxygen atoms with an overall 1 negative charge. The negative charge indicates that the ion has more electrons than protons. The chemical formula for an ionic compound must contain the lowest whole number ratio of ions needed to make the compound neutral. The total positive charge from the cations must equal the total negative charge from the anions so that the overall charge is 0. The subscripts in a chemical formula indicate how many of each ion is needed. The positively charged cation is always written first in the formula. For example, sodium ions have a 1 plus charge and oxide ions have a 2 negative charge. 2 sodium ions are needed to balance the charge of 1 oxide ion, so the formula is N2O. Sodium ions and chloride ions have charges of 1 plus and 1 minus, so only one of each is needed, giving NaCl. Calcium ions have a 2 positive charge and oxide ions have a 2 negative charge, so one of each ion is needed, giving CaO. However, calcium ions and chloride ions require 2 chloride ions to balance the charge of the 2 positive charge on calcium, giving CaCl2. Ionic compounds containing polyatomic ions must also have charges that add up to 0. The polyatomic ion behaves as a single charged unit. Parentheses are used when more than one of a polyatomic ion is needed in the formula. For example, sodium ions have a 1 plus charge and carbonate ions have a 2 negative charge. So 2 sodium ions are needed for every 1 carbonate. The formula is Na2CO3, and parentheses are not needed because only 1 carbonate ion is present. Similarly, sodium ions and hypochlorite ions have charges of 1 plus and 1 minus, so the formula is NaClO. Calcium ions have a 2 positive charge and carbonate ions have a 2 negative charge, so one of each ion is needed, giving CaCO3. However, calcium ions with hypochlorite ions require 2 hypochlorites to balance the charge. The formula is Ca parentheses ClO close parentheses 2. The parentheses are needed because the subscript 2 applies to the entire polyatomic ion. Parentheses are only used for polyatomic ions, and they are only needed when more than one of that polyatomic ion is present. Consider the two formulas NaClO2 and Ca parentheses ClO close parentheses 2. The first compound contains 1 sodium ion and 1 chlorite ion. The formula contains 1 sodium atom, 1 chlorine atom, and 2 oxygen atoms. In the second formula, there is 1 calcium ion and 2 hypochlorite ions. The subscript 2 applies to both the chlorine and the oxygen atoms inside the parentheses. Therefore, this compound contains 1 calcium atom, 2 chlorine atoms, and 2 oxygen atoms. The parentheses help clarify whether the subscript applies to the entire polyatomic ion or to one element within the ion. A common strategy for determining the subscripts in an ionic compound is the crisscross method. In this method, the charge of the cation becomes the subscript of the anion, and the charge of the anion becomes the subscript of the cation. This works because it helps us find the lowest common multiple between the two charges. For example, aluminum ions have a 3 positive charge, and oxide ions have a 2 negative charge. Using the crisscross method gives us Al2O3. This formula contains 2 aluminum ions, giving a total charge of 6 positive, and 3 oxide anions, giving a total charge of 6 negative. The charges cancel, resulting in a neutral compound. However, the crisscross method sometimes requires simplification. For example, combining calcium ions with a 2 plus charge and oxide ions with a 2 negative charge would initially give Ca2O2. However, both subscripts can be divided by 2, and ionic compounds must be written using the lowest whole number ratio. Therefore, the correct formula is CaO. Here's a practice problem. Write the chemical formulas for the ionic compounds formed between the following ions. The cations are listed in the first column, and the anions are listed across the top row. Before we begin writing chemical formulas, let's identify which ions are polyatomic. The first cation is ammonium, NH4+. This is a polyatomic ion because it contains multiple atoms, 1 nitrogen atom and 4 hydrogen atoms. The other two cations, cobalt 2 positive and tin 4 positive, are monatomic ions because each contain only one element. For our anions, the first anion is N3-, which is a monatomic ion because it contains only nitrogen. The other two ions are oxalate and hydroxide. Both oxalate C2O4 2- and hydroxide OH- are polyatomic ions. Remember, we use parentheses anytime we need more than one of a polyatomic ion in a chemical formula. Let's begin by combining the ammonium cation, NH4+, with the nitride anion, N3-. Look at the charges in the upper right corner of each ion. We need to determine what combination will create an overall neutral compound. 3 ammonium ions are needed to provide a total charge of 3 positive, and 1 nitride ion provides a charge of 3 negative. The charges cancel, giving the formula parentheses NH4 parentheses 3N. Because there are 3 ammonium ions. Next, let's combine the ammonium with the oxalate ion. 2 ammonium ions are needed to balance the 2 negative charge of the oxalate. Since there are 2 ammonium ions, parentheses are required. Parentheses NH4 close parentheses 2 C2O4. When ammonium combines with hydroxide, NH4+ and OH-, only 1 ion of each is needed. The formula is NH4OH. No parentheses are needed because there is only 1 of each polyatomic ion. Next, let's move on to the cobalt cation, CO2+. When cobalt-2+ combines with nitride, N3-, we first need to find the lowest common multiple between the charges. The lowest common multiple of 2 and 3 is 6. We need to have a total of 6 positive charges and 6 negative charges. This requires 3 cobalt ions and 2 nitride ions, giving us the chemical formula CO3N2. When cobalt-2+ combines with oxalate, C2O4 the charges are equal and opposite. 1 cobalt ion balances 1 oxalate ion, giving us COC2O4. No parentheses are needed because there is only 1 oxalate ion. When cobalt-2+ combines with oxide OH-, we need 2 hydroxide ions to balance the 2 positive charge of the cobalt. Since there are 2 hydroxide ions, parentheses are required. CO parentheses OH close parentheses 2. Lastly, we have the tin 4+ cation. When tin 4+ combines with nitride N3-, the lowest common multiple between 4 and 3 is 12. We need to have 3 tin ions to provide positive 12 charges and 4 nitride ions to provide negative 12 charges. The formula is SN3N4. When tin 4+ combines with oxalate, we need 2 oxalate ions to balance the charge of the tin. Since oxalate is a polyatomic ion and there are 2 of them, parentheses are required. SN parentheses C2O4 close parentheses 2. Remember that the subscripts inside a polyatomic ion are not to be changed or simplified. Oxalate will remain C2O4. Finally, when tin 4+ combines with hydroxide OH-, we need to have 4 hydroxide ions to balance the 4 positive charge of the tin. Since there are multiple hydroxide ions, parentheses are required. SN parentheses OH4 with the 4 outside the parentheses. When using the crisscross method, always remember to simplify the subscripts to the lowest whole number ratio if needed. However, the subscripts within the polyatomic ion are never simplified because those represent the fixed composition of that ion.